The answer is yes, they are. Two rational expressions, they have x in the denominator. Furthermore, they also have in the numerator. Fine. If you remember when we multiplied numerical fractions, we always simplified first. But I can't simplify because they're not factored yet. Don't multiply. We simplify first, but I can't because they're not factored. So we have to start slowly with the numerator. How do you factor x squared plus x? Now, x minus 7, we cannot touch because it is what it is. It's a linear factor. It's done. But the rest have to be completely factored, otherwise we cannot simplify. Good? How will you factor x squared plus x, please? Anybody, please?
X minus 1, x plus 1.
Careful. We always start with the strategy. It's in descending order. It's a binomial. There is a greatest common factor. Yes.
I'll factor out x, I guess.
That's it. What is left?
X plus 1.
Indeed. Done. Now we are here.
X minus 7, x minus 1.
Perfect. Now we are here.
X minus 1, x plus 1.
At this point, I cannot simplify anything before I state restrictions. One from here, which is the same, and one from here. And the restrictions are? Anyone?
7,
Yes?
positive 1, negative 1.
That's it. Now we are safe, and now we are allowed to simplify. So, an x minus 7 from the denominator with an x minus 7 from the numerator. An x plus 1 from the denominator with an x plus 1 from the numerator. The final answer will include the restrictions. Can anyone give us the final answer?
X over x minus 1.
Squared. X over x minus 1 squared, assuming x is never 7, positive 1, negative 1. Very good. Good. Any questions on this? Okay, moving on. Here's another one. X plus 2 times x minus 9 over x squared minus 7x minus 18. Remember, x plus 2 is basically x plus 2 over 1. Otherwise, it will be 1 over. There is no ambiguity there. Good. Completely factored, but this is not completely factored. So I have an x plus 2, if you want to write it over 1, times x minus 9. And now we have to write the factored form of the denominator.
X minus 9, x plus 2.
X minus 9, x plus 2. We cannot simplify before we state restrictions.
9 and negative 2.
9 and negative 2. And now we're ready to simplify. So, an x minus 9 from the top when we write 1, with an x minus 9 from the denominator we write 1. An x plus 2 from the top, from the bottom we write 1, and x plus 2 from the top. The simplified form, if you don't write 1, you may consider it 0. So please write 1. Good. So then the simplified form is
Just 1.
just 1, only with a condition under the condition that x is never 9 or negative 10. Perfect. Okay, let's look at division now of rational expressions. Division of rational expressions. So x minus 4 over 5x minus 20 divided by 13x over 5. Let me refresh your memory on something. Here, in a product, we are allowed to simplify across. Never in a division. You have to wait till you change it into a product. You cannot, even if you could simplify something like this, it's not possible. So careful. So I am allowed to simplify the fraction by itself if it's possible. I'm allowed to simplify the fraction by itself, top with bottom, but not across in a division. Good. So now x minus 4 is very clear. But what about the denominator? Can anyone factor the denominator, please?
Did you pull out the 5?
Indeed. What is left in print?
X minus 4?
X minus 4. Don't simplify anything. We have to state restrictions first. Now 13x over 5, I divide. There's nothing I can do here, so I have to change it into multiplication, 5 over 13x. Now I have to state two restrictions, and only then I'm free to simplify, not before. From here, what restriction will I write?
4?
Very good. From here, what restriction will I write?
Negative 13?
Careful, this is not plus. 13 times what number will be 0?
0.
Exactly. Good. So now I'm free to simplify. I'll simplify a 5 from the top with a 5 from the bottom, and I write 1. I'll simplify a factor of x minus 4 from the top with a factor of x minus 4 from the denominator. Including the restrictions, what is the final answer?
1 over 13x.
1 over 13x. 1 over 13x. Very good. Very good. Let's look at another. Any questions on this? Any questions on the division? Okay, so let's work on x squared minus x. Everything divided by x squared minus 1 and further divided by x plus 1 over x squared plus 2x plus 1. So let's take it slowly. We cannot touch anything just yet. Everything has to be fully factored. Let's fully factor everything and then decide the next step.
Factor out the x in the top left.
Very good. So what is left once I factor out x?
X minus 1.
Very good, excellent. The denominator?
X minus 1, x plus 1.
Yes. Still keep it as a division for now. I'll explain why. The top is x plus 1. Nobody can do anything to that. What about x squared plus 2x plus 1? If you skip the special product, you're making it more difficult.
X plus 1, X plus 1.
Indeed. So we write x plus 1 squared. Good. Excellent. So let's look at the denominators only and identify the restrictions. And then we can change it into a product. Any restrictions, please?
1,
Yes? 1 from here,
-1,
-1, plus or minus 1. Good. Excellent. So now we cannot simplify across, but if we can simplify each fraction by itself, I will definitely do it. Not across. I see that the first fraction can be simplified by a factor of x minus 1. I see the second fraction can be simplified by a factor of x plus 1. I did not simplify across in a division. That's not allowed. I simplified each fraction by itself. So therefore, now I have the first fraction, which is x over x plus 1. Now I change the division into x plus 1 over 1, because there is nothing else but 1. Now, there are no additional denominators. Sometimes when I flip, a new denominator pops up, so I may have to increase this list of restrictions, but not here. It's 1. Okay, is there another factor that I can get rid of?
x plus 1,
Indeed, 1 from the top and 1 from the bottom. So the final simplified form is x, but actually the correct answer includes the restrictions. The simplified form of this division of two rational expressions is plain x, only under the condition that x is never ever going to be plus or minus 1. Okay. So we are given a rectangle, and they are telling us that the length is x plus 9 over x squared minus 3x. They're telling us that the width is x squared minus 9 over x squared minus 81. They want us to find the area and fully simplify it. They want us to find the area and fully simplify it. What is the area of the rectangle? What is the formula? Anyone remembers the formula? Can anyone remind us the formula for the area of the rectangle?
Length times width.
Very good. Length times width. So I'm going to copy them. Length, x plus 9 over x squared minus 3x multiplied by x squared minus 9 over x squared minus 81. I can't touch anything till I completely factor everything. The top x plus 9 is a linear factor. No one can do anything to it. What about the denominator?
Factor out x.
Good. What is left in parentheses?
X minus 3.
Excellent. So now we reached x squared minus 9.
X minus 3, x plus 3.
Finally, we reached x squared minus 81.
X minus 9, x plus 9.
Good. Restrictions first, and then we look back.
3, -3, 9, -9.
0,
0.
0 from here, 3 from here, plus or minus 9 from here. This factor cannot be 0. This factor cannot be 0. This cannot be 0. This cannot be 0. And now we want to clean it up. Let's clean it up. An x minus 3 from the top with an x minus 3 from the bottom. An x plus 9 from the bottom with an x plus 9 from the top. What is the simplified form of this expression? Of the product of the two areas. Of the two dimensions for the area.
X plus 3 over x squared minus 9.
X minus 9.
X.
So, very good point. So, of course, the actual answer is x plus 3 over x times x minus 9, assuming that x is never 0, 3, plus or minus 9. And this is a very good remark. Keep denominators fully factored. Do not expand denominators.
So I'll put x squared and 9 minus 9x.
It's not incorrect. It's perfect to write x squared minus 9x. Please do not.
Okay.
It's correct. We always want the denominator to be fully factored. For restrictions and for many other situations. Is it incorrect to write this? No, it's perfect. Both are perfect. But please remember, moving forward, it is the best, and it's a waste of time to do this. It's correct, but it's a waste of time. We always want denominators to be fully factored. For many other applications that follow in math. The numerator, no. The numerator, we want it completely factored as well. We don't want it expanded. But definitely the denominator. We don't want to expand the denominator. Okay, a similar problem. We have a triangle. They're telling us that the base is 48x over x squared minus 7x plus 6. And for some reason, they also give us the height. And they want us to find the area of this triangle and fully simplify it. So the area of the triangle is the same, base times height, but it's divided by 2. It's the same with the length times width, if you want, from the rectangle, but it's divided by 2. And remember, we can also write this as 1/2 times the base, which is 48x over x squared minus 7x plus 6, times the height, which is x minus 1 over 4. Yes, when it comes to numbers, we can immediately simplify if we want to. And why not? So I can simplify by 4 and get here 12. And simplify by 2 and get here 6. This is fine because I simplified only factors. 2 is a factor in the denominator, 4 is a factor in the denominator, and 48 is a factor in the numerator. Now, I will continue. I have 6x in the numerator over x squared minus 7x plus 6 times x minus 1 over 1. Obviously, I have to factor this. So I have 6x over times x minus 1 over 1, and I will have to write 2 restrictions.
X minus 6, x minus 1.
Very good. And minus 6, x minus 1. And the restrictions are, so I can simplify. I have to state the restrictions before I simplify.
0.
No,
6.
there is no factor of x. We don't state restrictions for the top.
6 and 1.
6 and 1. Good. So now I will simplify an x minus 1 from the denominator with an x minus 1 from the numerator. And this is the only thing I can do and this is 6x over x minus 6. Do not try to simplify the 6. 6 is a factor here, but it's not a factor here. So this is the simplified form, assuming that x is never 1 or 6.